To begin this lab, we will use transfer pipettes to transfer all of our prepared stock solutions to their own cuvettes. As you can see, my hands are very steady, but you want to make sure that the meniscus of your dilution rests directly on top of the fill line of the cuvette. Because we are using the spectrophotometer, we have to prepare a cuvette with water in it to have a blank to zero the spectrophotometer. This water is filled to the line where all the other solutions is filled to, shown here. To begin your time in the spectrophotometer room, begin by wiping both sides of the blank water cuvette before you go to zero it. Okay, he's putting it in, and now he's going to close the door and press 0 on the computer screen. After you have zeroed your spectrophotometer, you want to begin by using your stock solution to scan across all wavelengths to find the perfect wavelength to scan across. After you have found this, begin by scanning all of your solutions, your dilutions and your unknown dilutions, to find their absorbance values. Make sure that you record these absorbance values down in your notebook because you will need these to plug into the lambda max formula to find the molarity of the unknown solution later. After we have determined the wavelength that we should scan at, which is 600 nanometers, we begin to scan all of our dilutions. As you see, he is placing the dilution in the spectrophotometer, and he will run scan and record the absorption value that is shown on the screen. When he is done recording the absorption value, he will remove the cuvette and repeat this process for all of our cuvettes that we have remaining. Beer-Lambert law is a law that assumes that the absorbance is directly proportional to the concentration of a substance. The absorbance plus the concentration also has a linear relationship, which is shown in the graph. Also, failing to zero the machine would account for the absorbance of ammonia in the solution, which we only want copper when we record the absorbance. We use a blank solution that contains everything except what we want, which is copper, to take out the NH3 of our copper amine solution. Beer-Lambert law states that absorbance is equal to molar absorptivity times path length times concentration. This provides us an equation to plug in when we have our absorbance to find the molarity of our solution. With your time in the spectrophotometer room up, return to the lab and clean up your workspace, making sure to wipe it down. Use your absorbance and the Beer-Lambert law equation to plug in and find your molarity of the unknown substances. This is the end of the lab.